In this video, we will discuss manipulating equilibrium expressions. By now we have seen the equilibrium constant expression, and we realize that we can write it from either the forward or the reverse point of view. So if we have the equilibrium between hydrogen iodine and hydrogen iodide, under some conditions it has an equilibrium constant of 1.23 times 10 to the negative 2. However, if we write this same reaction in the reverse direction, we have a new equilibrium expression, here denoted by Kc apostrophe, also known as Kc prime, and therefore it's going to have a different equilibrium constant. Now, since we just flipped the equilibrium quotient, we're just going to write the inverse of the equilibrium constant, recalculate it, and that gives us an equilibrium constant of 81.3. Which makes sense. Based on our first reaction, we saw that this favored the hydrogen and the iodine. So if we write the hydrogen and the iodine as reactants, we're going to get a very small number, but if we write them as products, we're going to get a very large number. Nothing has really changed about the conditions or the equilibrium constant, we just are showing it from a different point of view. So what else can we do with the equilibrium constant? Well, for instance, as we've seen in thermochemistry, we can double the reaction. So for instance, if we write all the stoichiometric equivalents multiplied times 2, well, that's going to change our equilibrium expression. Now, if we look at this, we realize that we've just taken the original equilibrium expression and raised it to the power of 2. Therefore, we need to raise our original equilibrium constant, Kc, to the power of 2, and that gives us a new equilibrium constant. Let's do that again with the same reaction, but slightly different. Let's take the same reaction and let's cut all of the stoichiometric coefficients in half. And again, we see this is the same as taking our original equilibrium expression and raising it to the power of 1/2, or taking the square root. Therefore, if we want to find out what the new equilibrium constant is under these new conditions, we just take the square root of our old equilibrium constant, and we get our new value. Combining equilibrium expressions is something that's very important. Let's take this pair of reactions. This is actually one reaction that takes place over 2 steps. We have NOBr breaks down into nitrogen monoxide and bromine, and the bromine goes on to react with chlorine to make bromine chloride. Each one of these steps is an equilibrium, and it has its own equilibrium expression and constant associated with it. But what if we wanted to find out what the overall equilibrium constant was? Well, if we want to find out the equilibrium expression for the overall reaction, we need to find out what the overall reaction is. So if we add all the reactants and all the products, canceling the bromine, because that's just an intermediate and it doesn't show up on the final reaction, we get this new equilibrium expression. Well, if we notice, this is just the other 2 equilibrium expressions multiplied times each other, canceling out the bromine. Well, if we add 2 reactions, and that ended up multiplying their equilibrium expressions, then that actually just multiplies their equilibrium constants, which gives us our new equilibrium constant for our overall reaction. Here we see an overall view of what can be done to an equilibrium expression and how it affects the equilibrium constant. Use this as a guide for determining how to combine and manipulate equilibrium expressions.